Good morning, everyone, and thank you for joining the CMPC Pulp Mill Efficiency Challenge webinar. I'm Carlos Espejo, project manager of this challenge. I'm very pleased to acknowledge that I'm joining you today from the traditional, ancestral, and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh nations. Now, allow me to introduce you to our colleagues from CMPC. Sebastian Corton, Senior Innovation Engineer at CMPC and project manager of this challenge from their end. Candelaria Briceño, Innovation Engineer, Cristian Fajardo, Head of the Water and Effluents Unit, and Diego Soto, Research and Development Engineer. From Foresight, we have my colleague Heather Crouchetier, Director of Innovation Challenges, and myself. Today, we have up to 1 hour to cover the topics included in the agenda. As you can see, this will include 30 minutes of questions at the end. We will talk about the challenge sponsor, CMPC, and Foresight, the delivery partner. We'll talk about the challenge, its importance for CMPC, some key dates, the application process, and finally, we will have those 30 minutes for questions. The webinar is being recorded and it will be posted on the challenge website for future reference. Note that CMPC is based in Chile, so if necessary, we may need to translate some of your questions to their technical team to ensure all of them are accurately answered. Now, Sebastian, project manager of this challenge from CMPC, will tell you a bit more about their company. Sebastian, please, if you don't mind.
Thank you, Carlos, and thank everyone for being here. I would like to tell you a little bit about CMPC, our company. Well, CMPC is one of the biggest pulp and paper company in the world. We have, by far, 47 industrial plants across 8 countries right now. This company was born in 1920 with the production of papers and cardboard, and today we have been growing a lot, and today we commercialize our products through our 3 main business: pulp, biopackaging, and softies, that is tissue products. And by now we reach more than 26,000 direct clients around the world. Next slide, please, Carlos. So here in CMPC, we have a corporate purpose that we call the 3 Cs. That is to create, coexist, and conserve. And this purpose is integral to CMPC's way of doing business and guides our action and operation towards a sustainable future. So one of our objectives here is to reduce waste generation, but by promoting circular economy management, reuse, recycle, and recovery are vital operations for us in order to achieve it. So we have been really committed to reach this goal, and by now we have reduced the annual final disposal of non-hazardous waste by more than 280,000 metric tons since 2018. Thank you, Carlos.
Thank you, Sebastian. Now that you know more about the challenge sponsor, allow me to introduce you to Foresight. Foresight is Canada's clean tech accelerator. Our main goal is to fuel the transformation to a green economy across the country, with the final objective of helping Canada to be the first net zero economy in the G7. We hope you will join us as we support the growth and commercial impact of clean tech in Canada and around the world. There is a lot going on in Foresight, but we can divide our activities in basically 5 areas. We have our acceleration programs, where we support companies in different stages and sectors to accelerate their technologies, scale, or commercialize their solutions. As you all know, because that's why you are here, we also run innovation challenges for industry partners that want to improve their processes or reduce their environmental impact. Also, we support companies in capital attraction and help them to reach other markets. Finally, we connect the different stakeholders in the sector using our Helix 5 model. These stakeholders are innovators, industry, investors, government, and academia. We are very proud of our impact. We have helped over 870 SMEs, and they have raised over 1.2 billion Canadian dollars since 2015. So yeah, we like to track what we are doing and what we have achieved so far. Lastly, one major thing that I want to highlight is that for us, it's very important to ensure the industry demands the technologies we promote and accelerate. So we run these innovation challenges to ensure this innovation is market-driven. Now we will hear from Candelaria about why the challenge is important to them and which problems or which risk are they facing or they are trying to solve at the moment. Candelaria, please.
Thank you, Carlos. Well, I'm Candelaria Diseño. I am an innovation engineer at CMPC. And at this challenge, we seek for innovative solutions to recover fibers from the wastewater sludge processes during our pulp and paper manufacturing. We aim to find a technology solutions that allowed us to obtain as dry as possible products from our sludge so we can use it afterwards, with the potential of a pilot opportunity in the for the most interesting technologies. Next step. Next one, please. CMPC is a global leader, part of a new era that challenged companies to move from linear economy to a circular one. As Sebastian mentioned, it is our values, and it drives this challenge objective. The challenge background is the result of the separation of solids in clarifiers, a primary sludge rich in cellulose fibers, and in a secondary sludge rich in biological matter are generated in our processes. This challenge is expecting to allow CMPC to be more efficient in using these fibers, treating the sludge and recovery a high potential materials by increasing the percentage of solids. So next one, please. How we do it today? I don't know, Carlos or Heather, if you could help me pointing the process. If we go from left to right, in our processes in the pulp and paper, we have an integrated mill that has pulp and paper processes. We produce two kinds of effluent. The first one is the high solids effluent, and the other one is the chemical effluent involved in all the chemical processes internally at the mill. In the high solid effluent, first it goes through a screener where it removes all the big residues that are contained at this effluent, like nodes of the wood chips, or other things that are not really tiny sizes as fiber or water. It comes to the primary clarifier where it separates the primary sludge, the primary sludge, and then the rest of the effluent go to a neutralizer. The primary sludge goes to the sludge tanks where it is contained before it goes to the process section. For the other side, in the chemical effluents, it is a really acidic effluent. So first it goes to a pre-neutralizer and joins the primary effluent at the big neutralizer. This passed through some steps in between, like the cooling towers, the biological reactor, the aerator, before reaching the secondary clarifier, where we could reach the secondary sludge that is mostly biological material. So this secondary sludge goes through the sludges tank in a concentration or a proportion with the primary of 80-20 between the primary sludge and the secondary sludges. And these two mixed go to the presses that is more like a band filter presses to reach a dry content between 20 and 30%. So with this dry content, we can go and mix it with the biomass for burning these sludges. Why do we burn it? We burn it to not have residues at our mills. And with this concentration or these dry solid contents of the sludges, it's really difficult to manipulate it or reuse it in other sites or other mills. So we have to burn it, not to present them as residue. And what we want to do, please the next slide. So the principal challenge here is to separate both of the currents of the sludges and concentrate in the primary sludge, where the most of the content of fibers that we can reuse in other processes. So for reuse it in other processes, we need to take this sludge that comes in a dry content from the clarifier about the 10% or less of dry solids to take this sludge and up to or over 50% of dry solids. So we can manipulate it and transport it to another pulp mill, another paper mill, or the molded fiber mill, where we could use it to produce end products. So that is our first challenge that we have at CMPC, is how to reach that amount of dry content with our sludge, how to take off all the water from the sludge and make it and without changing the fibers composition or the fibers structure, so we could use it then for paper production or molded fiber production. For the side, we will have the secondary sludge that is a much more or less amount than the primary sludge, and it's most of the biological material. So this cannot go as waste. So we have all I forgot the word. we have this secondary sludge that we must reach up until this 20 or 30% of dry solid, so we could burn it and not discard it as residue. So for first site, we are really concentrated on the primary sludge, so we could have those fiber available for producing paper or molded fiber products. And in the second side, we have what to do with the secondary sludge, not to have them as residues.
Perfect. Thank you so much for explaining the challenge in detail, Candelaria, and letting us know that details about the specific dry contents that we need for both the primary and the secondary sludges. Now that you know the background, main objectives of the challenge, and how the current process works, let's talk about the key dates of this challenge. As you can see, the challenge launched on September 6th. Today is 27th day on the information webinar. Applicants still have one more month to submit their applications, since the submission window closes on October 28th at 4 p.m. Pacific time. After screening to ensure completeness and that the solutions align with the challenge objective, we will have an evaluation period by CMPC. Once this evaluation period is completed, Foresight will reach the shortlisted applicants and schedule pitch presentations with CMPC on the 1st and 6th of December. After these pitch sessions, the winner or winners will be announced. Regarding the eligibility criteria, this challenge is open to all categories of applicants and project collaborators. This includes technology developers, institutions, SMEs, multinational enterprises, and research laboratories. Obviously, the proposed solution must align with the challenge topic and reach the specific percentage of dry content that Candelaria specified, and it must be between TRL 7 and 9, both included. The application process is fairly straightforward. First of all, candidates will need to register on the competition website. It is necessary to access the application form. After that, they will need to complete the form, and they will receive a confirmation email once they submit it. It's important to note that after you submit your application, you won't be allowed to edit it. Once we receive all the applications, we will have an initial screening to ensure they fulfill the eligibility criteria before sending them to CMPC for review. Then, the most promising solutions will be required to present their technologies to CMPC in a pitch session, as I just mentioned in the key dates. The most interesting solution or solutions will be selected as winners of the challenge and potentially pilot their technology with CMPC in one of their facilities. Finally, I would like to highlight some tips for the application process. These are, please make sure you fulfill the eligibility requirements, because we are going to screen them before sending these applications to CMPC. Please don't wait until the deadline to submit your applications. This one is very important because there is always a risk of an unexpected technical problem that could affect the hour of your submission. and the platform will automatically close at 4 p.m. Pacific time. So please do not wait until the last minute to submit it, because in previous challenges we had the experience of losing potential applicants due to this reason. We also recommend to provide data evidence where required to support your qualitative descriptions. We recommend to use clear language in technical section of your technology or project. And finally, we recommend that you explain the work you have done today to progress your technology until its current situation. Also, keep in mind that for any challenge-related questions, you can contact us at challenges@foresightcac.com. With that, we can begin the Q&A of the session, which will be managed by my colleague, Heather Crochettier, Director of Innovation Challenges at Foresight. Heather, please.
Thanks, Carlos, and thanks, Candelaria and Sebastian, for your fantastic presentations. Please, if you have questions, feel free to use the Q&A function. We have one question in there from Aaron Morrison, which may have already been answered in the presentation, but Aaron, feel free to maybe add to the chat if you have more specifics that you're looking for. But the question is, what percentage of reduction does that equate to? Aaron, if you could provide a little bit more detail in the chat, that might be helpful so we can make sure that we're answering the question properly.
I can answer this one. As I understand, Aaron is expecting the percentage that the number I gave, right? So I can't really give you that percentage, but I can tell you that we have the goal of being a zero waste company by 2025. So that can give you, it makes you understand what we're looking for. We want to be a zero waste company by 2025, and we are working really hard to achieve that.
Great, thanks, Sebastian. Question from Vic, what are the specs for feed to the paperboard secondary product? Candelaria, do you want to take a crack at that?
Yes. If I understand correctly the question, we expect to use the whole of the primary sludge on the production, not of paperboard, and maybe thinking about corrugated cardboard and molded fibers. We're an integrated company, and we're expecting to use like the whole amount that we could use from the primary sludge on this production.
Thank you. Okay, we have another question. Do we have the specification of primary sludge, AKA?
If you mean as a characterization, we don't have it. We could manage if you need like specific criteria. It is an alkali solution. It comes from an alkali solution, and it's most of fibers, bleached, unbleached, softwood fiber, and also from the paper production, from extensive paper production. So all of those kind of fibers.
Great, thank you. Question, why not move the secondary product process closer to the primary output?
Carlos, I don't know if you, si me puedes ayudar ahí. O sea, Cristian, perdón.
Okay, so maybe we can go to the slides of the process and see exactly what he is referring to. It's here. So he's suggesting why not move the secondary product process closer to the primary output.
I know that this is most because this is an effluent treatment, so we need to reach the clean effluent to return it. So we need to do all this treatment, the cooling towers, done the biological processes for these sludges, and then reaching the secondary clarifier, the aerator in between is needed because of the microbiological treatment. Cristian, no sé si tienes algo más que agregar de por qué no se hacen más cercanos la obtención del lodo primario con el secundario.
No, es netamente porcentaje de producción, Candelaria.
Perfecto.
Candelaria, disculpa, ¿a qué se refiere exactamente la pregunta? ¿Que quieren acercarlo físicamente? ¿Que quieren acercarlo o quieren acercarlo en términos de humedad?
Vic, could you please clarify a little bit more your question? Do you mean like putting them closer in the percentage of dry content, or closer like physically closer during the process? You could give us more information about your exact question, because we are a little bit confused about what exactly are you asking here. Thank you. And while you clarify that, I think we can move to the next question, Heather, until Vic clarifies the question a bit more.
We're looking for a little bit more detail on eligibility criteria. Carlos, maybe you can take that one.
1 second, Vic clarified the question at the end. Slide help, let me rephrase. What needs to be done to the primary sludge to be effective fit to corrugated paper? So, Candelaria, can you please provide detail on that one?
Yes, we only need like to drain as much as possible this sludge, so it is we can manage and handle it and do all the transportation without transporting too much water, because today it's in between 20 and 30% the most dry content that we could reach with this filter presses, and this is not this doesn't allow us to transport it to our corrugated paper mill, so we can reuse that fibers.
Okay, thank you. So now moving to the next question. Is there a specific application format that we use? So, I mean, yes, the format that we are looking for the primary sludge, as you can see in the slide, we are looking for a format that allows us to be handled and reprocessed. And for the secondary sludge, I believe is in bulk format. Can you confirm that, Candelaria? Or Sebastian?
Sorry, I missed a bit of the audio. Which was the question?
The question, is there a specific application format that we use? And for the primary sludge, we need a manipulable format. And for the secondary sludge, I believe it's bulk format, right?
Yes, for the secondary sludge is just reaching to the 20 or 30% of dry content, and that we will mix it with the biomass. We don't need like a specific format.
Okay, thank you.
Okay. Carlos, could you provide more detail on the eligibility criteria?
Sure. So let me move to the slide. As you can see, the eligibility criteria is very open for this challenge. You could be a technology developer, academia, institution, research laboratory, SME, or multinational enterprise. As long as your solution is aligned with the challenge topic, allow CMPC to reach the percentage of solids that they are looking for in the primary and secondary sludges, and you are at a technology readiness level between 7 to 9, both included, you are eligible to participate.
Great, thanks, Carlos. Next question is wondering about the ownership of the proprietary process that they have. So will they retain ownership of their process?
Yes, of course that the winning applicant will retain the ownership of the proprietary process. Yeah.
Okay, next question. Do you have any sludge chemistry data, things like alkalinity, metal concentration, types of organics, etc., that you're able to share?
Yes, Theo recently told me that we do have a characterization of the primary sludges. I don't know if we could share it in the webpage after this meeting.
Yeah, if you are allowed to share that with us, we can put that concentrations in the website of the challenge. That's not a problem.
Yes, we will see which is the critical information that we could give and which is the information that is not public.
Yeah, the confidential one. Perfect.
Yes.
Yeah, and especially in that matter, it would be very helpful if you can provide which information do you want from the characterization of different. If there is something specific that we can give you.
So,
Yeah.
Shade, if you could please send us an email to, let me put the email address on the screen, to challenges@foresightchc.com with the specific information that you need. We could try to answer your specific question. Thank you.
Okay. We have a question here from Paul Boudreau, who has had discussions with CMPC in the past, says hello to Sebastian. Regarding technology to turn secondary sludge into biopolymer for production of bioplastic. They're wondering if this is a potential eligible project for this challenge.
Hi, Paul. How are you? Nice to hear from you. As I remember the last time that we talked about BOSC, it was we thought to use it with the sludges from Cordillera in Santiago, and here we're thinking about the sludges in Laja, that is the pulp mill, not the paper mill. So there is a difference there. But if you can show this project also for this challenge, it would be great. So we can compare the solution with other solutions. It would be great to hear from this project again. Thank you.
Sebastian. Next question, wondering, have you evaluated the impact of sending only secondary sludge directly to the power boiler mixed with biomass?
Yes, it's the biggest problem that we have just sending the secondary sludge is the high content of water that is difficult to process in the press filter, because it's too much water in it and it doesn't remove anything. It's just the water drains all together with the sludges. So if we move it for mixing with the biomass, like the transportations, it's really hard, because it goes all over the tracks, and that is some residues that stays there at the way in between the sludges and the effluent treatment part of the mill and the rest of the mill. So that is the biggest problem that we have of just sending the secondary sludges as it to the biomass.
Great, thank you. Next question is, what is the bacteria level of the sludges post Mbbr treatment and aerator treatment?
So that's here. Well, it's in the current process. It's here right before the aerator, I assume. Oh no, it's after the Mbbr and after the aerator, just before the secondary clarifier is the question.
Yeah, so the question is, what is the bacteria level of the sludges after the Mbbr treatment and aerator treatment? If you're able to share anything about that.
Cristian, ¿tenemos ese número de el nivel de bacteria antes del...
En concentración de sólidos suspendidos totales, en la salida del Mbbr es de 57 miligramos litro, en comparación a la cámara de aireación, que es de 4.100 miligramos litro.
Pero eso es de lodo.
Concentración de sólidos suspendidos totales.
Ya, pero no tenemos el de bacteria.
Es que en la salida de la cámara de aireación y del Mbbr es considerado la población microbiana.
Perfecto, entonces 57 mil...
57 miligramos en base 50, a SSD. Sólidos suspendidos.
Son ppm.
Perfecto. 57 57 solids per milligrams per liter after the Mbbr. And then, ¿a cuánto subimos después del aerador, Cristian?
3.800, 4.000 en el parámetro de control.
And after the aerator, we have 3,800 or 1,000 milligrams per liter.
Okay, thank you, Christian, and thank you, Candelaria.
Next question, wondering if there will be funding support for conducting pilot demonstrations for the successful candidate.
Short answer, yes. The long answer, I want to note here that it's not that the winner solution is gonna have a pilot to CMPC and we can say that it's gonna be a pilot. It's important to notice that the winner it's gonna work together with CMPC to refine this proposal, to have a good proposal, and that we're gonna present it again in order to have the approval to make this pilot. Okay, so if there is a good proposal and we work together with the winner in order to create a good proposal and it fits with what we're looking for sure there's gonna be a funding from CMPC in order to make this pilot. Yes.
Great. Thanks for that clarification, Sebastian. Next question, are you interested in treating both the liquid effluent to recover the fibers as well as the treatment of the sludge line in the process, greatly reducing the need for pressing and burning?
We are looking for all kinds of solutions, but in the matter of mixing both sludges, we contaminate the primary sludge that is mostly fibers that we could use like for really good quality products with the biological material that is contained at the secondary sludges. But we are open to seek all the solutions that you could refer about these challenges.
Perfect, thank you. We have another question wondering if a confidentiality agreement was signed, does CMPC feel comfortable disclosing more details about the process and sludge characterization?
For sure.
Yeah, for sure. But I think the first step is to apply into this challenge, and then if there is a company, there's a solution that goes to the next step, I think there is a step to sign this confidential agreement. Not now, but after the application.
Yeah, as I just want to highlight here that, as we mentioned during the presentation, after the first screening process, just to ensure that the solution aligns with the challenge objective and the TRL level is between 7 to 9, these applications will be reviewed by CMPC. So if any application is interesting to them, they are going to shortlist it and it will have the opportunity to sign this confidentiality agreement in the future, but they will review the applications and consider if they are what they are, if this application is what they are looking for.
Okay, next question. How many gallons of water do you use in your cooling towers to cool down the wastewater?
Cristian, ¿cuánta agua se usa en las torres de enfriamiento? Más o menos.
Mira, lo que pasa es que no sé si entendí bien la pregunta, pero están utilizando cuánta agua se utiliza para el efluente, porque no es la función de las torres. Las torres bajan la temperatura de nuestro efluente, de nuestro río.
Sí, Cristian. Están preguntando cuánta agua usan para enfriar el efluente. ¿Cuánta agua usan las cooling towers?
No se utiliza agua para enfriar el efluente. Las torres se utilizan para enfriar el efluente.
Yeah, what Tristan said is our cooling towers are atmospheric. We don't use fresh water to cool the effluent. Only the effluent and the atmospheric phenomena that cools the effluent. So there is no water involved.
Okay, thank you.
Next question is, what is the total dissolved solid concentration in milligrams per liter of the primary sludge?
Cristian, ¿cuántos son los sólidos del lodo primario?
No se hace ese análisis, ese control operativo no se lleva a cabo.
Okay. Sorry, Saida, but we don't have that number.
Sounds good. Maybe there's an opportunity to follow up there. If the person's still wondering, feel free to send us an email. And the last question that we have for now, although we still have time if folks have other questions come up, is what is the liquid volume to be pressed, i.e. the liter per day or liters per hour?
¿Se procesa diario más o menos, Cristian?
¿De agua?
Sí, de fluente.
70.000 metros cúbicos día.
70,000 cubic meters per day.
Hey.
Ahora yo creo que esa última pregunta igual está apuntada al volumen del lodo primario que deberíamos procesar, ¿no? Que creo que es como el desafío más cercano. No sé si Cristian tiene ese dato.
¿Qué cosa, Sebastián? Disculpa.
El volumen del lodo primario que deberíamos procesar.
Sí, mira, son 56. 168 metros cúbicos día.
Okay.
168.
168 metros cúbicos día de lodo.
Okay, so just to translate the conversation, Sebastian was asking about what's the volume of primary sludge that they need to treat, and the answer is 168 cubic meters per day.
Thank you, Carlos. We have a question wondering, do you currently purchase nitrogen and phosphorus to treat the wastewater?
Cristian, en el proceso de tratamiento de agua, ¿hay nitrógeno y fósforo involucrados o no? ¿Sí?
Sí, se dosifica en el sistema de lodo activado en la cámara de aireación. De hecho, en la parte del Mbbr se dosifica nitrógeno y fósforo. Nosotros controlamos una concentración de nitrógeno en base amoniacal de 2,0 y en lo que es fósforo de 0,8 miligramos litro.
Yes, we do use nitrogen and phosphorus in the microbiological reactor or the bioreactor. The concentration of the nitrogen is 2.0. ¿Cuánto era la concentración de nitrógeno?
2 miligramos litro.
2 milligrams per liter, and the phosphorus 0.8 milligrams per liter.
How much primary and secondary sludge do you produce per day, looking at a dry solids basis?
I think this one was answered in the last question.
Yeah, but I think that the previous question was is with water, so it's 168 cubic meters. Let me translate this one to Christian. Christian, están preguntando que cuánto es el volumen de lodo primario y secundario en base sólida, sin agua.
En base sólida no tengo ese valor, no es algo que se lleve como control operativo. Se saca solamente en el volumen indicado. Ahora, en lo que es el lodo secundario, se extrae 3 litros segundo de forma constante.
Okay, 3 liters per second. Okay, so to answer your question, we don't have the number in dry solid basis because they track it with water. They track the total volume of sludges. So for the primary sludge, as we previously mentioned, is 168 cubic meters per day. For the secondary sludge is 3 liters per second. So yeah, I have to do the number, but it's 3 liters per second.
Yeah, it can be taken using the solid content. You can do the
yeah,
calculation.
Of course, yeah, you have the ratio. If
yes,
you go,
the 20 and 30%.
It's in the slides. It's in the slides,
Yes.
Carlos, if you
yeah,
can show it.
we go to this slide, if we have the volumes and the dry contents appear here in the slide, that's the amount of
the previous one, please.
And the previous one. Oh yeah, this is the goal. This is the current ratio.
Yeah,
So
here it is.
Is less than 10% for the secondary sludge, and the volume is 3 liters per second. And for the primary sludge,
For the mix, sorry, that's not the primary, that's the mixed.
Yes, sorry. And for the mix, the dry content is 20 to 30%, and the volume is 168 cubic meters.
And the mix here in the sludge tank is 80% for the primary sludge and 20% for the secondary sludge. So if you can make some math in order to have some estimated numbers.
Okay. We have some more questions coming in. Do you use polymers for dewatering sludge? And if so, what is the approximate cost?
Cristian, ¿hoy día usamos algún polímero para...?
I think Christian is having connectivity issues because his camera is frozen.
Okay. Maybe we can go to the next question and see if he
Reconnect.
is able to reconnect. Okay, so does the primary sludge have value if it could be managed separately from the WAS? Oh, it looks like Candelaria might also
Yes,
be
I
frozen.
think we lost Candelaria to Diego. Do you have the answer for this question?
For the first one, we do use polymers for dewatering. I don't know if we can disclose the cost, but it's like the standard polymer. And the second one, it's what actually Candelaria and Sebastian presented, that we have more value we can manage separately. Like the primary sludge, you can use it as an alternative fiber source, and the secondary sludge can be used directly for biomass boiling.
Okay, thank you. We have another question around cost, which may be the same restrictions there, but are you able to share an approximate cost per year for nutrients, specifically nitrogen and phosphorus?
Yeah, the same. I'm not sure we can disclose that. If we are in advanced step with an NDA, we can share that information.
Great. Thank
So
you.
yeah, Eric, you send us that question to the challenge website. If CMPC is allowed to share that number, we can share that number with you. If they are not, then it's confidential and we won't be able to share it.
Okay, that's all the questions for now. And Candelaria is back, which is great. Maybe we'll give folks another couple seconds to see if they think of any questions. And do feel free, Carlos did share the email address, and we can put it back up on the screen. If you think of questions later, do reach out to us at challenges@foresightcac.com. Happy to respond to any inquiries there as well. Oh, okay. Another question come in. How about the polymer dose per ton of sludge in kilograms per ton? Are you able to share any information about that? Oh, I think you're on mute, Diego.
Diego, yeah. Oh, he's in the phone, I think.
Oh. Candelaria, are you able to respond to this question? Welcome back.
Sorry, I have some troubles with the internet. It goes off for all the company, I think.
No problem.
Could you repeat the question?
Absolutely. Wondering about the polymer dose per ton of sludge in kilograms per ton.
Yes, Carlos, ¿sabes cuánto es la dosificación de polímeros por tonelada que se aplica?
Cristian.
O sea, Cristian, perdón.
Pero también se cayó.
Yes, I think it's something for all CMPC. Everybody at the office also turn off the internet. So I don't have the answer right here, I don't know if Diego is over there because I joined from my iPad. I don't know.
Yeah, I was talking with Christian because he had a problem with the connection. He says that it's an anionic polymer, but the ratio he is calculating. But we can give that information after. I don't know if it's that possible.
Okay, sure. So please send this question to the challenge email address, and once we have the number from Christian, we will let you know.
Perfect. Another question is the 168 centimeters per day raw liquor, or is it the diluted stream?
It's not it's not centimeters, it's cubic meters, I think.
Oh, yes, cubic meters. Yes.
That's the volume. So
Yeah, is this a question for
It's for the
they're
amount.
asking if the secondary waste is the raw liquor or the diluted stream? That should be the raw liquor.
I think the volume was for the, if I'm not mistaken, Christian said that the 168 cubic meters per day was the primary sludge
Yes, it is.
volume.
It's the mix of sludges.
That's the mixed one, yes.
Yeah.
Yes, the mix that we obtain at the tank over there, that is 80% primary and 20% secondary. That is 168% cubic meters.
Okay, so let's give a few more seconds, and if that's everything for now, we can finish the webinar. Please, those questions that we couldn't answer and any other question that you may have, just send them to the challenge email address, challenges@foresightcac.com, and we will be happy to answer them once we have the information. Thank you all for your time, and yeah, looking forward to see your applications to this challenge.